Hey guys, hope you're doing good. So it's 10 and I think I don't see anyone yet. So let's wait for a couple of minutes, a minute or so, and then we can get started. So the agenda of this live session is so I'll be basically discussing the how arrays are stored in memory, and then basically operations in array and their time complexity and space complexity, and basically then I'll move to dynamic array and their its internal implementation, and then some questions like why does indexes in array start with from 0 and not 1. So some sort of questions like this. So I'll not be taking any coding question in this session because the time is very limited and I won't be able to jump to questions, but yes, I'll complete the theory part and the internal implementation, and then in the end I'll also show you the Arraylist code in Java. So the class which Java provides the Arraylist, I'll show you how does it how the code is written internally inside Arraylist class in Java. So I'll wait for some a minute and then we can get started. So I just see 20 people online and I got responses of around 140, I guess. So, and I asked you guys like if you're willing to join, then only tell me yes, else don't write yes. So I was not expecting such a less number. So if that's the case, I'll definitely take up the session because I committed to take the session, and then but I am afraid I won't be able to take any further sessions because it's very difficult for me to take out time for taking these sessions, and then you guys are like doing like this, firstly saying that we'll join and then not. So but it's okay, I'll look into it. So I hope the audio and video is clear. Let me see the comments. So just tell me in comments that audio and video is clear. Great. So so I don't have a good number, but still it's okay. Let us basically start. Let's not waste much time waiting for others, and we can get started. So I already told the agenda for the basically my this session. Let's directly jump to the first topic, that is how are arrays stored in memory. So I'll basically share my screen. Let me share my screen. So I hope you guys can see my screen now. Maybe I'll so I think I need to add my video, then only it will record my audio. So I think now you have the audio. You guys, can you guys hear me now? Comments? Still not audible. Audible. Audible now? Perfect. So I was just saying, in and no matter in which language you code, so you don't do something like when you declare an array, so you do something like this. So basically int and then array, then basically your array name. So let's say my array, and then you are declaring it like new int 4. So I just check once again. Yes, all good. So what entire what is happening internally? So what do you expect when I do such a statement? What internally happens is, so basically you would know that the size of integer, this in my Java is 4 bytes. So what is happening is, so since I'm allocating 4 such spaces, so compiler basically does is, so it allocates space equals to 4 into 4, that is 16 bytes. And this space is contiguous. So wherever it finds 16 bytes of contiguous space, it allocates it, and then basically saves it for this array. So this is how, like, the when you write such a statement, the compiler basically allocates uh, this amount of memory in contiguous space. On what does the compiler remembers? So basically, let's say this is the contiguous space, it is being, and it's allocated, and the address of first point is 4000, let's say. And basically since it is like 4 into 4, 16 bytes, so it will go on, and basically you can refer any index. So what does compiler remembers here is, so compiler remembers the first address. So since the compiler remembers the address of the first byte of array only, so and in fact the address of the first byte is considered to be the memory address of the entire array. So this first address, basically compiler remembers this address and stores it at the address of basically this array. So whenever the compiler needs to refer to this my array, so basically for this for the compiler, the address stored is 4000. And now you would say that how it can refer all the other remaining elements when it just remembers the first address of the first byte. So basically this magic happens because the size is fixed. So you know that if first address is 4000, then you would have a chunk of contiguous 16 bytes, and then you can find the address of other remaining elements. So I'll show you how. So till now, let's see the comments. I think everything is going good. Great. So let's move. So basically, knowing the address of the first byte, the computer can easily calculate to find the address memory address of any other elements. So for example, given this is our like my array. So what you need to retrieve any nth index. So what compiler does is, so the computer goes to the address of array. So array address of array is 4000. So what it does is, let me just erase this stuff. So let me erase. So okay, so what it does is, so it sum the address of array. So address of array, so which was 4000 in our case, so it will do 4000 plus n into m. And what is n, what is m? So n is the basically index you are searching. So for example, you want to retrieve my array n. So this is n, so basically the index which you want to retrieve. And what is m here? So m is the basically size of the type you are storing in the array. So in our case, we are storing integer in the array, which is of 4 bytes. So what exactly it does is, so for example, you need to find my array of 3. So what it does is, so it basically adds the index of array, address of array, which is 4000 in my case, plus n is 3, and then m is 4. So it will do 4000 plus 12, so which is 4012. So using this computation, it can directly reference third element in the array. So so this is how, like, basically you can the compiler can reference to any n in the array, since we know the size of each element being stored in the array, and the compiler remembers the address of first byte of the array and stores it at the address of array. So I think great teaching, sir. Okay, so I think so far so good. Let's move. So uh, if you guys have any question till now, you can basically post in the comments. I can look into the comments later on. um, okay, so I think the first part, that is memory management, how arrays are so how basically arrays are stored in memory, and then basically how using the first byte address of array, compiler can reference to the any index in the array directly. So I also mentioned in the agenda point that why the index in array starts from 0 and not 1. So this is the reason. So I just told you the reason, because since the compiler does something like adding the index of array plus n into m. So in this case, if I am referring to nth, basically n is equal to 0. So if I'm doing my array of 0, so what it does is 4000 plus 0 into m is 4, so which is 4000. So this is why the index of array starts from 0 and not 1, because uh, when we want to find the return the first element in the array, basically n needs to be 0 so that it returns uh, the first element. So also one thing you would be wondering is like, just by knowing the address. So since I did my array of 0 and I got the address of 4000. So but you would say that the element in the array is of 4 bytes, so it's stored on 4000, 4001, 4002, and 4004. So it's stored in 4 bytes. So how by just one retrieving the first address it can return. So basically what happens internally is, so when the compiler gets the first address, basically address of first byte of that index using this formula. So this formula is used to get the address of first byte, and then basically it returns the uh, it from there. So when the address which it gets from this operation, this formula. So basically in my case, in my 0th case, I got address as 4000. So what compiler will done is, for compiler will start from this address and return the value present at the chunk uh, till basically size of the element present in that index. So basically m, so here m is 4. So I know my each element is stored in 4 bytes. So starting from 4000, so I'll add 4 in it. So 4000 till 4004. So it will return the value present there. So this is how, by just knowing n, so by we can reference any element n by just knowing the first address and by knowing the size of the element stored in that address. So by using this formula we can just retrieve the first address, and then by adding the size of each element we can retrieve the last address, and then we can return the value stored in those addresses. So I think this thing is clear. So let me just erase it and we'll move it further. Okay, I think so far so good. I don't see much comments yet. Great. So let's move on to the operations we can perform in array. So the first and first operation is like accessing, basically reading any element. So which I just discussed, like doing my array of 3, my array 3. So I just discussed what happens internally, and basically when you do this, what does compiler do? So when you are reading an element from an array, so it's constant time. And why constant time? I already explained you. So what it does is it basically finds the address of that first byte using the formula, address of array plus n into m, and then basically return the value stored till basically starting from this index. So let's say it's 4000, and then it will go till the size of element, so it till m. So in my case is 4, so 4000 to 4004, it will return the value present there. So it's simple. So these mathematical calculations are over time. So retrieving from array is constant time, because we can directly jump to that index. We don't need to traverse the entire array. So we can just directly traverse using this formula. We can just directly go to that particular index, and compiler can return the value. So that's why it is over time. So and basically return this. So this is how the get operation works. So this operation is constant, and it just because it's just mathematical operation of addition and multiplication to finding the memory address, and it does not involve any loop or any iteration over the entire array. So they also one more thing to note here is, so this does not depend on the size of the array. So your array can be huge, but this get operation is constant time, because no matter if your array size is 10, or if your array size is 100, or if your array size is 1000, so it will still take the constant time, because you are not basically here you don't see any the size of array. It's just the first index, the n is the index which you need to retrieve, and the size of each element in the index. You don't have the count here, count of elements stored in the array. So that's why this operation get is does not depend on the size, and it remains constant. So this is like time complexity. What about space complexity for this operation? So since I'm not using any additional variable, or I'm not taking any space which is proportional to size of array, so it's constant time. So time and space complexity both for this operation is constant time. So I hope the get operation in array is clear to you. So let's move on. And before moving, I need to check the comments. I need to see if you guys have any doubts, or it's good to proceed. What is the initial value of array when the array is declared? Okay, so by value, what do you mean? So do you mean the address which is stored, or do you mean that the the content of that array, or are you referring here to the garbage value being stored in Java or something like that? So I don't understand your question. So maybe you can put your exact question again. So let's move on. So let's like jump to the another operation which we can perform in array. So so let's talk about insert. So what happens when we insert an element in the array? So let's say this is our uh, so let's say this is our array. So I have elements like 1, 4, 5, 7, 9, 10, 12, 13, and my size of array is basically it's more than that. So let's say my size of array is this, and I have already inserted basically these many elements, and then I need to insert more elements. So at the end, so basically I can insert let's say I say insert 7, so I can insert at the this index. Then I say index insert 8, then I can insert 9. So till basically in the initially I declare the size. So when I told the size was 4, so it allocates space for four elements. So I can insert only 4 elements in this. So like 1, 2, 3, 4. And if I at this point of time I say that I need to insert more elements, so it will not allow me to insert, because this the size of array is defined, and it only have space for these many elements. So you can't insert any more further element here. So uh, so so this is the limitation of array, that you can't dynamically scale the array. You can't increase the size of array basically in real time. So that's why we have dynamic arrays, and we have dynamic arrays so to solve that problem. So so basically this insert when you are inserting any element. So let's say you have only one, and then you have 4 spaces in your array, and then you need to insert 2. It's okay, fine, you have space. Then you need to insert 3. It's okay, you have space. So now only one space is left, and you can only insert one element. So this is the limitation, as I already told you. So to solve this, we have dynamic arrays. So let's basically talk about dynamic arrays, and then it will be more clear like how does copying and other stuff works. So let's talk about dynamic arrays, and then we can move back to insert again. So before moving to dynamic array, let's also discuss another operation, which is like copy. You can also perform an operation copy on the array. So what time complexity would copy operation take? So when you need to copy, what you need to do is you need to iterate over the entire array. So let's say you are given this array, and you need to copy it to a new array. So what you need to do is you need to iterate over each element, and then one by one copy all these elements to the new array. So you are at the first element, you copy it to a new array, then you come to the next element, you copy, and then so on. So this is how like copy works. So copying an array to a new array is O n time, because it depends on the size of the array. So the number of elements, the more the number of elements, the more time it will take. So it's like directly proportional to the size of array, so it's linear time. And similarly, since we are copying an element to a new array, so we are taking size which is equal to the size of array. So the time complexity and space complexity both are O of n. So this operation is you need to know the time complexity and space complexity of this copy operation, because this will really be required when you try to understand the dynamic array, because there the copy is very common. So you should be very clear about what's the time complexity in copying. So let me check if you have anything else. Okay, so let's move back to our original insert operation. So let's say we have a size of 4, and I already have 4 elements in the array. Now I say insert 5. What do you do in this case when you need to insert one more element? So the only possible option is you need to increase the size of array. But how do you increase the size of array? You cannot dynamically increase the size of array, because these are not dynamic arrays, these are static arrays. So how do you do it? So one possible way is create a new array of size. What would be the size of the new array? The size will be the size of previous array plus 1, because you need to insert one more elements. So now you know that if you create a new array of size which is equal to the size of previous array, which is 4, and then plus 1, so it will be 5. So now you can store 5 elements in this array. So you will copy the existing elements here, 1 2 3 4, and then the new element which we need to insert 5. So you will copy you will insert 5 here. So this is how, if you need to insert in a static array, so what you can do, so basically you can copy and basically create a new array with increased size and then copy. So what is the time complexity of this operation? It is O of n, because you are doing an entire copy, and I already told you the what is the time complexity for copy and space complexity of copy. So both will be O of n. So insertion in array is getting costlier, because each time, because after the size is exhausted, each time what you are doing is creating a new array, increasing size by 1, and then copying entire array. So inserting an element is insertion is getting costlier. So how to solve it? So basically this is where the dynamic arrays come into picture. So what exactly dynamic array do is, so I'll take example of Java. So when you declare array list in Java, so let's say array list integer, my array is equals to new array list integer. So you don't specify the size. Did you specify the size? So you don't specify the size. So how come, like, how much space is allocated for this array, and how does compiler know how much space to give to this array? So this is handled entirely internally. So I'll show you the code of this array list class in Java. But before that, I'll explain you on this board. So what Java does is, so it initially it allocates a space for 10 elements. So if you are if you need to store integer which is 4 bytes, so it will allocate space of 40 bytes. 10 into 4, 40 bytes. So now what happens is you can store 10 elements in this array. So let's say you are storing elements, so you said 1 2 3 4 5 6 7 8 9 10. Now what? It's the same. You ended into the same situation which was in the static array case. So now if you want to insert 11, how do you insert 11? Because the size is finished. But you know that this is dynamic array, so there should be some magic going on behind the scenes that so that you can insert, you don't need to care about the size. So like on the similar grounds which I told you away in the static array, that you can increase the size of array by 1 and then copy the entire array. But increasing size by 1 is like not performant. It's not the optimal case, because each time you need to insert an element, if you keep on increasing size by just 1, then it will take on time. So how to make it o1? So since you know that dynamic array insert is o1, so how to make it o1? So basically what happens is, so in Java, what Java does is, so basically whenever the size of array is exhausted, which means that you have finished the size of array, and now since you want to insert 11, now array checks that Java checks that yes, my size of array is fixed full. Now I need to insert the array, insert the size. So how much size is it increases? So basically it increases size by 1.5 times. So it will basically, initially my size was 10, now it will add half of it. So basically it will add 5 more. So I have 5 more empty spaces now, and then basically I can insert 11. So next I need to insert 12, 13, 14, 15. So one thing to note here is, so just a second. So one thing to note here is, uh, when you basically, for these operations, like for 1, insertion was o1, for this was o1, for 3, for 4, 5, 6, 7, 8, 9. So for all these 10 operations the insertion time was o1. For this 11, what was the insertion time? It was o of n, because I had to copy the entire array, that those 10 elements, to a new array of size 15. So I did basically from my initial array of size 10, I copied these 10 elements to my array of 15. So my insertion time was O of n, which is like O of 10. So next, for 12 the size is O1, for 13 the size is O1, for 14 the size is O1, and then for 15 size is O1. And now if I need to insert 16, what is that is, it does the same thing. Like it will increase the size by one size of current array plus like 15 plus 15 by 2. So it will increase the size again. And similarly for inserting 16, it will take on, and then for remaining elements which are free, it will take o1. So essentially what you are doing is, so uh, let's say you have array of just let's say, like, since Java does this o10, so to in this to so basically now I'm explaining you why do we call it o1 as a whole and not on, because generally you are being taught that we take the worst case. So you can say that since the worst case of insertion is on, and no matter it is for very few elements, but the worst case is on, so why not we call it on instead of o1? So I am explaining that stuff now. So just a second. So let's say my size of array is just 1. So I can insert 1 in it. Now I need to insert one more element. So what basically, if we just don't go by Java and that just go by normal concepts, that it keeps on doubling every time. So let's say it doubles. So now I can insert one more element. So this was o1. Now what is this inserting 2? So it's o2, because I need to copy the elements in next. So now basically, now what happens is, basically if I need to insert, so basically this insertion of o2 will be o of 1, because I need to copy array of one size. Now what happens is, if I need to insert one more, it will double. So it will basically do 4 times. So now I have can insert 3. So insert 3 will be o1, insert 4 will be o1. Now I need to insert 5. So what, for inserting 5, what I need to do is I need to double again. So basically to double, basically what will happen, I need to copy 4 elements. So it will be uh, here basically, here it was for 3, it was copying 2 elements, so it was o2. Now for 5 it will be copying 5 elements, so it will be o of 4, and then so on. Basically for now I will do double 8. So basically for the ninth element I need to copy 8, so it will be o of 8. So this is how, like, in the middle you have o of 1, o of 1, o of 1, and then basically in the for n you have series like o of 1 plus o of 2 plus o of 4 plus o of 8. So you are getting this series. And basically last time basically for the n, in the end, for n operations, what will be basically for last time we did n operations, second time the second last we are doing is n by 2, and then n by 8. So what so basically this is like what is happening. So let's say this is n, so it is 4 is n by 2, 8 by 2, but is 2 it's n by 4, and then n by 8. So this is like a series. So this is like you need to solve this series in maths. So this is like simple basically. Let me do it small. So series look like n plus n by 2 plus n by 4 plus n by 8, and which converges to 2n. So if you conceptually basically if you solved it to so basically it will converge to 2n. And basically in asymptotic notation for O of 2n, it's equivalent to O of n. So that's why, because since if you solve this series mathematically, it converges to 2n. So that's why we are not calling it O of n. Rather, basically we are calling it O of 1. So also if you look conceptually, so since you see like O of 1, O of 1, O of 1, and then so you just see once O of n. So if you see like multiple O of 1 and then 1 or 2 O of n, so that's like conceptually also it looks like it's O of 1 and not O of n. So I think this is clear. Let's move. So you don't need to go in that detail like solving that AP and stuff. You just need to know that this is just the case that you're not taking the exception, the worst case, but you are just taking the average here, that which will come at O out to be O1. So uh, now let's understand basically you know that insertion, how insertion in the end basically is O1, but insertion in the middle. So let's say if you need to insert here and you already have 1 2 5, well, means you need to insert like I have this array and I need to insert at third index. So basically I need to insert between these two. So for this stuff, still I need to basically shift all the remaining elements to a next position. So what I will doing is I'll shift all those elements ahead to further next position. So it will be O of n. So inserting in the middle or inserting in the starting or beginning, so it's like O of n and O of n. And same for delete. Delete also we need to shift the elements. So delete also works the same way as insert. So deleting and insertion, it will take uh, O of n. And similar to delete, similar to insert in end, delete in the end is also O of 1. So if I compare insert and delete and then search, so beginning, middle, and end. So search is O1 everywhere. So insert is in the beginning is O of n, in the middle of is O of n, and in the end it is O of 1. And delete is same, beginning On, middle On, and the end it is O1. So this is the table you can like use to refer to the time complexity of basically of arrays. So now let's see the internal implementation of Java, Arraylist in Java. So I'll just walk you through the code which is inside, which is written by Java. So I'll stop sharing this screen and move to different screen now. So let me add my screen. I think so far so good. So can you guys see my screen? Just a yes would work. Can you guys see my screen? I don't see a yes. Can you guys hear me? Am I the only one in the live session? You guys are here? Let me check on my phone. What is that? Okay, now I'm getting messages. Perfect. Perfect. Let's move. So yeah, okay, cool. So this is the way like you can declare the array list in Java. So since I told you that initially when you declare the array list in Java, it basically the size of that array list is 10. So let's confirm that. So if I go to the implementation of array list class in Java, so basically this is the array list class, and if you see the package, it is java.util, which is written by Java. So now let's let's see what happens when you basically when you are doing this constructor, calling this constructor of array. So what it says, it constructs an empty array with initial capacity of 10. So this is what I told you, that it will create an initial empty list with initial capacity of 10. So you can also confirm this. So they have a variable default capacity which they are using to initialize the array. So basically this is 10 in your in Java's case. So whenever you are doing this stuff, it's creating an array of 10. So now let's do check the code of add function. So my array dot add. Let's see the add function here. So if I open the implementation of add function, what it is doing is, so it's basically incrementing the count, that number of elements in that, and then calling the add function, one more overloaded function of that, the main add function. So let's see what's internal. So what it essentially is doing is, so if it's checking that if the size of my array is equals to the element length of dot length. So if the number of elements present in my array has reached the the size of the array allocated by Java. So it will basically, let's say, this will become true when you initially you insert 10 elements. So this if condition will true. So what happens now is, it says element data is equals to grow. So it will call the grow function. So let's see what happens inside the grow function. So what it is saying essentially is, it says grow size plus 1. So what is size plus 1? So it's the minimum size it wants, because the size is current size. This size variable is basically in this size variable, Java stores the current size which is being which has been allocated to the array list. So I'm saying that I want to grow the array, and the minimum size I want is the current size plus 1, which is the minimum, because I need to insert one element. So at least I want size which is greater than my current element by 1. So I'm calling this grow function. Let's see. So this was the as I told you, the minimum capacity we passed. So now what happens is, it's doing the copy. So it's calling the internal copy of basically function. It's basically copying the our old array to a new array. And what happening is, so basically it's telling the new capacity function, this new capacity function is finding the capacity of a new array. So what's happening internally is, so if we go inside the new capacity function, so it says the returns the capacity at least as large as the given minimum capacity, and returns the capacity increased by 50% of its suffices. So basically initially we have the 10 sizes 10. So when we want to insert the 11th element, the capacity will become 10 plus 5, which is 15. And it also checks that the size of array does not increase the maximum size, which is possible, and other stuff. So let's see. So basically they are not doing the basically they could have done something like this. uh, so they could have done something like old capacity plus old capacity divided by 2. So they didn't prefer to use the divide operation to increase the size of array. So what they preferred was they did the right shift. So what essentially is right shift? So when you are doing a right shift by 1, you are dividing the number by 2. So what is happening is old capacity plus old capacity by 2, which is essentially increasing by 50%, which is mentioned. So this new capacity is found out like this. And then like this is mentioned that it will not return capacity greater than the maximum array size. So this condition is here. So it is checking that basically like this, when new capacity minus minimum capacity is less than equals to 0. So basically this is to check that we are not doing an overflow by increasing the capacity. So this check is being done here. And then in the end also I'm checking this condition that the overflow is not there. So if it's not there, then I'm returning the new capacity, and if it's there, I'm returning the basically huge capacity, that is the maximum capacity of array can store. And what is the maximum array size? It's the basically integer dot maximum value. The maximum value an integer can have -8. What is why 8 is subtracted? Because some VMs reserve some headers in an array, so that's why 8 is subtracted here. So I think now the internal working, basically how does Arraylist works internally, basically how does it grows, and by how much percent it grows, and then the grow function, the new capacity function, and then checking for the overflow and other stuff, it's clear to you. So it's like quite beneficial, and it's quite useful in the interviews if you have the in-depth knowledge of this stuff. So whenever you are using array list in front of interviewer, he might ask you like any do you even know that how ArrayList grows internally, or how ArrayList works internally? So you can very well justify and say yes, I know, and this is how it works. So that will leave a good impression on the interviewer. So he will be very highly satisfied, and then you can use other functions and other classes in Java itself. So knowing the internals of each data structure is very must. So this was the basic one. That the array is very basic, and I think almost all of you, or above 80 or 90% of you guys, would be aware of these concepts already, but it's always good to brush up. So I think this session will help you, and then maybe you can now jump onto questions. So just spend as much time you can on questions of arrays. So there are different patterns which involves good array questions like perfect sum, sliding window, and then there are multiple questions which are combined, which like arrays everywhere. So when you do questions for hashing, arrays there. When you means like arrays the basic, so you should not skip the easy and medium or hard questions for this. And like median of array, find the product, uh, question like find the product array, which is the product of all the elements except the current element and stuff. So like there are multiple questions which arrays involve. And believe me, interview can happen only on array as well. So like there are very difficult questions on array also. So don't think that array is simple, and then in the interviews people will not ask you about arrays. It's nothing like that. Believe me, it's nothing like that. And complete interview can also can also happen on arrays, and the people and the interviewer can very well judge you. So it's not like that array is not very, that's not that important, because I see people jumping directly to the linked list or stacks question. They just skip the array part, but they don't know that there are very important question. And also array, doing the basic questions of array help you in developing skills like how looping skills and other stuff. So it's very important to first clear up basics and then move to the advanced questions. So I hope this session was useful. So before closing of the session, let's like I would like to know that was this session useful or not. So maybe you can put comments here, or you can even put comments on the video, so that after the video uh, is available to everyone, so they can see the comments and figure out like if was it useful or not. So just for my sake, if you want, if you can comment and tell me if it was useful, and would it make sense for me to have such sessions on DS. And maybe plan a next I can plan a next session for arrays with discussing some important questions. So if that's the case, uh, just leave few comments, or maybe it would be better if you can leave comments on the video itself and not in the here in the live comments, so that I can reply as well on those comments. So by saying this, I'll sign off, and I'll just say one thing: keep learning, keep growing. Thank you. Bye.